Let's talk about how to use technology to find the least squares regression line. So in the calculator, we go to Stat, and we go to Tests, and it's option F, the LinReg T test. Notice this is the same function on the calculator we were using to get our correlation coefficient R and our p-value to determine linear correlation in section 4.1. Now, the book says that the equation is y hat equals b1x plus b0. And remember, b1 was the slope, and b0 was the y-intercept. In the calculator, the output tells us that y equals a plus bx. So in the calculator, b is the slope and a is the y-intercept. Okay, the instructions to do this in StatCrunch are right here. Once you open up the data from the problem in StatCrunch, you go to the Stat menu, then in the drop-down pick Regression, then Simple Linear, and then it'll have you select a column for the x variable and a column for the y variable, and then you just calculate. So let's go with an example using the TI-84. So here's that same data about club head speed and the distance in yards that a golf ball will travel. So we need to go ahead and put those into list 1 and list 2. You can do that while my calculator program is opening up here. So I think mine are already in there. Yes, I have those already. So I will go to Stat, over to Tests, and we want option F, the LinReg T test. List 1, list 2, nothing changes. That always stays like it is. So calculate. So now you can see, well, let's see if I can put this in a good spot. Here's where it says y equals a plus bx. It's the very first thing. The t is our test statistic. P is our p-value. We've already talked about that. And if we scroll down like we're going for our R, you see we have a and a b value. So determine if there's linear correlation. Well, if we go back up, and we've done this before, the p-value was 0.0005, and we were assuming that alpha was 0.05, so the p-value is less than alpha, which means there is linear correlation, right? We learned that in section 4.1. So now we need to find the regression line. So I'm going to bring the calculator back in here. So we have y hat equals, and remember the calculator's different. It says it's bx plus A. So let's write down what the calculator gave us. It gave us, I guess I'm going to have to move this out of the way, y hat equals B is 3.166x minus, because A is negative, 55.797. And I forgot we're supposed to round to 4 decimal places, so stick a 1 in front of the x, and we should have negative 55.7966 for the y-intercept. So find the predicted distance when the golf ball is hit with a club head speed of 103 miles per hour. We take our equation. Since we have linear correlation, and we just plug in 103 miles per hour for x, and I guess we really don't need the miles per hour, and then finish off with the minus 55.7966. When you put that in the calculator, we get a predicted value of 270.3117 yards. So that's an example where we do have linear correlation, and we use the equation to predict values. What happens if we do not have linear correlation? Well, we'll discuss that in the next video.